For the last 3 billion years, life on Earth has followed a single, unbreakable rule. Oxygen comes from the light. It is the product of photosynthesis. Sunlight hitting green leaves and algae, fueling the atmosphere that keeps us alive. We have built our entire understanding of biology and our search for alien life on this one fact. But recently, 13,000 feet beneath the surface of the Pacific Ocean, where the sun hasn't shone for eons, that rule was broken. Scientists discovered something that shouldn't be physically possible. In the crushing, freezing darkness of the abyss, the oxygen levels weren't dropping, they were skyrocketing. The seafloor was breathing, and it wasn't coming from a plant or an animal or a vent. It was coming from the rocks themselves. We have just discovered a dark oxygen factory hidden in the deep sea, a discovery that forces us to rewrite the history of Earth, rethink the potential for life on other planets. And it has triggered a high-stakes race between saving our future with green energy or accidentally destroying an alien ecosystem we didn't know existed. We thought we knew our own planet. We were wrong. To understand why this discovery is so terrifying to some and exciting to others, you have to understand the environment we are dealing with. The Clarion-Clipperton Zone is a vast fracture in the Pacific Ocean floor, stretching wider than the entire continental United States. Down here, the pressure is equivalent to having an elephant stand on your thumb. It is a world of absolute stillness. For decades, marine biologists assumed this was a low-energy environment. Oxygen down here is a finite resource. It drifts down from the surface and is slowly consumed by bottom feeders and bacteria. Once it's gone, it's gone. So when a team of researchers sent autonomous landers down to sample the sediment, they expected to see oxygen levels slowly declining as the organisms breathed it up. Instead, their sensors went haywire. The data showed oxygen was being produced at a rate that defied logic. At first, the scientists were convinced their equipment was broken. They pulled the sensors up, recalibrated them, and sent them back down. They did this for 10 years. Every single time, the result was the same. In the pitch black, something was pumping fresh oxygen into the water. They realized they were looking at a geobatari. The culprit wasn't a biological organism. It was the ground itself. Scattered across the abyssal plains are billions of black, potato-sized lumps known as polymetallic nodules. These nodules are essentially geological pearls. Over millions of years, dissolved metals in the seawater, manganese, nickel, cobalt, and copper, have slowly precipitated around tiny fragments of shell or shark teeth, building up layer by layer. We've known about them for a century, but we looked at them as lifeless rocks. What we missed is that these metals, arranged in these specific layers, hold an electrical charge. When the researchers stuck probes into the nodules, they found a voltage of almost 1.0 volt on the surface of a single rock. Now, 1 volt isn't much. It's less than an AA battery, but nature has a trick. On the seafloor, these nodules are packed together, touching one another, creating massive, naturally occurring battery packs. When the voltage across a cluster rises high enough, specifically above 1.5 volts, it triggers a phenomenon called seawater electrolysis. The electric current literally rips the water molecules apart. It splits the H2O, stripping away the hydrogen and releasing pure elemental oxygen bubbles. This changes everything. It means that long before photosynthesis evolved, long before the sun became the primary engine of life, the deep ocean might have been generating its own air. It suggests that life on Earth could have started in the dark, fueled by electric rocks rather than sunlight. The implications of dark oxygen go far beyond our own oceans. This discovery has given astrobiologists a new blueprint for hunting aliens. Until now, we have been obsessed with the Goldilocks zone, looking for planets that are close enough to a star to have liquid water and sunlight. We assume that without light, you can't have an oxygen-rich atmosphere, and without oxygen, you can't have complex, intelligent life. But look at our own solar system. Jupiter's moon Europa and Saturn's moon Enceladus are frozen worlds. Their surfaces are dead ice, but beneath that ice, they have vast, salty, liquid oceans. We used to think these oceans might only support simple microbes because they are cut off from the sun. But if the floors of Europa's oceans are covered in polymetallic nodules like Earth's, they could be generating massive amounts of oxygen through electrolysis. Dark oxygen means that complex, breathing life could exist in the darkest corners of the universe, completely independent of a star. However, back on Earth, this miracle of nature is about to become a casualty of human industry. The very same metals that allow these nodules to produce oxygen, cobalt, nickel, copper, are the exact exact materials we desperately need to build the green energy revolution. They are the essential ingredients for electric vehicle batteries, wind turbines, and solar storage. As we speak, mining companies are gearing up to harvest these nodules. The Clarion-Clipperton Zone contains more cobalt and nickel than all land-based reserves combined. Mining this area could secure our energy future for centuries. It sounds like the perfect solution. We get the metals we need without digging massive open pit mines in the rainforests. But here's the danger. We now know these nodules are active participants in the deep sea ecosystem. They are the lungs of the abyss. If we send massive robotic tractors down there to scoop up these rocks, we aren't just picking up litter, we are removing the oxygen source for a habitat we barely understand. The creatures down here, ghostly octopuses, translucent sponges, and organisms that have never been classified, may depend on this dark oxygen to survive. If we strip mine the seafloor, we could suffocate an entire alien world right here on Earth before we've even had the chance to study it. We are facing an impossible choice. Do we sacrifice the deep ocean to save the atmosphere above? The discovery of dark oxygen proves that the Earth is still hiding massive secrets from us. But the ocean isn't the only place where our map of the planet is wrong. While eyes are turned toward the Pacific depths, geologists in North America have stumbled upon another anomaly, this one hiding inside a volcano. The Cascade Mountain Range is a majestic line of fire and ice stretching from Northern California to British Columbia. It is part of the Ring of Fire, home to volcanoes like Mount St. Helens and Mount Rainier. Recently, researchers were mapping the rock structures deep beneath the Oregon Cascades to understand how magma moves. They expected the usual geological gradient. The deeper you drill, the hotter the rock gets. But the data didn't make sense. In the heart of the volcanic chain, deep underground, the rock wasn't getting hotter. It was staying cold. There is only one thing that can absorb that much heat from the Earth's crust: water. They discovered that the volcanic rocks of the Cascades are fractured and porous, acting like a colossal sponge. Trapped within these fractures is a hidden aquifer of staggering size. It is estimated to hold at least 19 cubic miles of water. To visualize that, imagine Lake Mead, the largest reservoir in the United States. Now double it. That is how much water is hanging suspended inside these mountains. It is roughly 162 trillion bottles of water. This discovery rewrites the hydrology of the West. It explains why the rivers in the high Cascades flow with a steady, icy, clear current even during the driest summers. The mountains are a natural water tower, trapping snowmelt and slowly filtering it through the rock over decades. But this sponge mountain reality comes with a volatile downside. We are talking about oceans of water sitting on top of active magma chambers. The Cascades are subduction volcanoes. They exist because the Juan de Fuca tectonic plate is sliding underneath North America. As that plate dives, it releases fluids that melt the rock above, creating magma that rises to the surface. When you have a massive reservoir of water interacting with a volcanic system, the physics of an eruption change. If magma surges upward and hits a water-saturated pocket, the water flashes to steam instantly. Steam expands to 1,600 times the volume of liquid water. This rapid expansion creates catastrophic pressure, leading to phreatic explosions, blasts of steam, and pulverized rock that can occur with little to no warning. Understanding where this water hides isn't just a curiosity. It is a matter of survival for the millions of people living in the shadow of these peaks. From the electrified, oxygen-producing rocks of the abyss to the hidden oceans locked inside our volcanoes, one thing is becoming increasingly clear. Earth is not a static rock. It is a dynamic, complex engine that operates on scales we are only beginning to perceive. We often look to space with a sense of wonder, imagining what strange phenomena might exist on other worlds. But the truth is, we are walking on a mystery. We are floating above a mystery. Every time we develop a new sensor or drill a little deeper, we find something that challenges our textbooks. The dark oxygen forces us to rethink the definition of life. The Cascade Reservoir forces us to rethink the structure of our land. It serves as a humbling reminder. As we race to geoengineer our climate, mine the seabed, and tap into the Earth's resources, we are tinkering with a machine we don't fully understand yet. And as history shows, when you mess with the unknown usually pushes back. If you want to keep exploring the deep secrets of our universe, from the bottom of the ocean to the edges of space, make sure you're subscribed. We dig up the stories that change how you see the world. Click the video on your screen now to dive into another mystery. I'll see you there.